we're going to pick up right where we left off in the video. So here we go. On your notes, front page. We're ready for number 5. What is the additive inverse? Problem number 5. What is the additive inverse? Let's start with B. 16, a plain number, is very good, Willow. Did you hear what Willow said?
Yes.
She said negative 16. The additive inverse is the same as the opposite. So the additive inverse is the same as the opposite. So the opposite of 16 is negative 16. Now, what about the other one? It's a little harder. What is the opposite of negative 3 plus pi? Derek?
3 negative pi.
3 minus pi, exactly, or 3 plus negative pi. That's exactly right. When we do the opposite, we change the signs, right, of everything. All right, number 6. Now, I know most of you can nail this. Distributive property. You remember what the distributive property is?
Yes.
It's the one that says you take whatever's out here and you times it by both of these.
Yep.
So what do we get when we do that? Willow?
12x squared plus 6xy.
Very, very good. Notice x squared because she had an x times an x. Very, very good. Wait a minute. What about this one? What am I supposed to do on this one? It says use the distributive property. What do you think I'm supposed to do? Derek?
Factor.
Factor. Very good. I love that. So what can I factor out, Derek?
Factor x.
This, I think that's it, isn't it?
Yep.
What will I be left with?
5x minus 8y.
That is like distributive in the other direction, go backwards in distributive. Anytime you factor, you're using the distributive property. Because if we do this, won't that bring us right back to our original? Very good. So C is going to be the same thing. What are you going to do with C?
Factor.
What are you going to factor out?
A squared.
An A squared.
And a
Let's
Z.
pause. Is everybody keeping up? We're going to take out an A squared. And how many Z's?
1.
1 is all we can take out because there's only 1 here to take out. So if we take out 2 A's and Z, what will we have left?
A plus
Z.
C to the 4th.
Beautiful. Beautiful, beautiful, beautiful. Would you try D on your own? Try it on your paper. Let's see how we do. All right, what'd you come up with for problem D? Anybody? Let's get somebody over here. Anybody over here? No, yeah. What do you think, guys? Is she right?
Yeah.
Perfect. Absolutely splendid.
Bless you.
Okay, big numbers here. What do you think?
Factor out 32.
Factor out 32. Willow says we can factor out at 32.
No.
Does 32 go into 160?
No.
My bad, y'all.
I believe it does, guys. I believe it does, 5 times.
Yeah, I'll bet you right.
So she takes out a 32, she's got 5A minus B. Very, very good. Very good. last one, who can give me the answer to this one? Anybody in the middle row here? Can you guys give me the answer to that? Yep.
-16 plus 21.
Oh, I love it. Did everybody catch the plus 21?
Yes, ma'am.
Yes, sir. You gotta remember to change all the signs. Very, very good. All right, you good on that section?
Yes, ma'am.
All right, moving on to the exponents now. We're gonna simplify exponent expressions. Now, lots of different ways to think about this problem, but I'd like you just to be open-minded and common sense. We have 3 x's on top of 2 x's. We're gonna be able to cancel, right?
Yeah.
Who has more, the top or the bottom? I'm talking about x's now.
The top.
The top. How many more does it have?
1.
So you are gonna have an x on the top of your fraction. Because xxx over xx is gonna cancel and leave you with 1 on the top. Now, what about the y's? What's going on with them?
More Y's
Bring it
on
to
the
the
top.
bottom.
More are on the bottom, so when I cancel, I'm gonna have my extras on the bottom. How many extras are there?
1.
1. So the answer is just x over y. Okay. Now B is a little bit trickier. First of all, it's a fraction, that always freaks us out, don't be freaked out. But it has a negative exponent. What do you remember about negative exponents, Willow?
When it's a negative, you flip it.
Exactly. Negative exponents move things from the top to the bottom and from the bottom to the top. They flip. So since this entire fraction has a negative exponent, the entire fraction is going to flip. If a fraction has a negative exponent, the whole shebang flips. Everything flips. Now what? We're not done. Now we have to square everything. So we'll have x squared, y squared, and don't forget this guy, 9. Everybody okay with those steps? All right, here we go. What are you gonna do with this guy? Gotta be careful. I know you want to cancel, but you have to be careful. We're going to cancel eventually. But see this right here?
Yeah.
We probably better deal with that. What's gonna happen here? What's that gonna become?
16x.
16x to the
4.
4th? We squared 4 and squared x squared. All right, now we're gonna start canceling. The 16 and 4 cancel.
Yes.
Yep, and leave you with what?
4
Where?
on the top.
On the top. 4 on the top. Now take a look at your x's. They're gonna cancel. Who has more? Top. How many extras does he have? 2. So you have x squared on the top. And y to the 5th. So I guess we don't have a fraction anymore. No panic yet, everybody good? All right, let's get the next one. Now it's time to panic. What a mess this is. Got a -3, I can't remember. direction to the negative, and we flipped the entire thing. We are not flipping this entire thing. Do you see the difference? Here the negative was on everything. Here it's only on individual items. So just those individual items are going to move. So this guy is going to come to the bottom. Everybody good? This guy is going to come to the bottom. He's not. He's staying up there. This guy's staying right where he is on the bottom. This guy, though, is going to go to the top, and he's going to stay on the bottom. Now, I'm going to stop right there. Does everybody follow what just happened? We do not like negative exponents. There's only one time that negative exponents are okay, and that's in scientific notation. Otherwise, we never want negative exponents. So, first step was to get rid of all the negative exponents by simply moving the individual items that had negative exponents. Nothing else moved. Now, look at the top of my problem, and I'm going to notice that nothing simplifies. That's just it. But on the bottom of my problem, can I put these two together? They're both x's. So how will they go together? What will that be? X to the what? 6. Very good. And then y cubed is 6. Now we can start canceling. No x's are going to cancel. How about y's? What's going to happen with my y's? 2 on the top. 2 on the top. And what's going to happen with my z's? Be careful. Remember, that's a 1 right there. So you did it first. What's going to happen with those? I'm going to have 5 on the bottom. Now, you might do that problem in a different order, a different way, and it's all okay. But this better be the answer you get. This is the answer. Okay, so if you want to do things differently, perfect. Make sure you're the right answer. Well, after that, this one's kind of easy. What do you think about this one? Anybody want to take a stab at it? X to the 6 over 27. Now, why, how did that happen, Willow? What did you do there? How did you do that?
Don't you multiply?
You do, when you have a power to power, you multiply. So, there are so many rules to memorize. If you could remember that, like Willow, that is super. If you can't remember it, stop and think about what this means. Doesn't this mean x squared times x squared times x squared? And that is x times x, x times x, x times x. So how many x's do I have? 6. If you can't remember the rule, you can always figure it out. She's right. And then where'd she get 27?
3 times.
3 to the 3rd. That's not 3 times 3. That's 3 to the 3rd. 27. Nicely done, Willow. Where's my, who's got my signature? Did we fill it out correctly, I hope? We'll see. And who's absent? Miles. Guess where Miles is gonna sit? All right. Now I'm gonna just call on somebody. If you don't know, we'll help you. Let's see. Stress? What do you think about this problem? I couldn't hear you. What? Okay, so step 1 is we're gonna flip this guy Why am I flipping the whole fraction? Because the whole thing is to the negative power. And she squared everything and she got the right answer. That's exactly right. Everybody okay? All right, now we're going to do some scientific notation. Have you all had chemistry? Yeah. So you have done scientific notation before? So if we have to write this number in scientific notation, who can summarize for me? What's our strategy? Who remembers? Leilani, do you remember? Nope, can't remember how scientific notation works. What about you, Eli? Do you remember? It's okay, I forget everything in the world, so it's okay if you forgot. No one remembers? When we do scientific notation, it's a simpler way of writing great big numbers or little tiny numbers. So in this problem, the decimal point is right there, 314,683. We're going to move that decimal point all the way so there's only one number in front of it. Now does it look familiar? We're going to move that decimal point so there's only one number in front of it. So now we have 3.14683. And because we moved the decimal point, we've changed the powers of 10. Well, how many places did we move the decimal? 1, 2, 3, 4, 5. So it's times 10 to the 5th. This number is how many places you moved it. So what's the rule? Only one number in front of the decimal. And in order to make that happen, you're going to move the decimal, and however many places you move it, that's this number. All right, 0.7136. That is going to have to move because we need a decimal place in front of it. So we'll move it one place. So now it's 7.136.
Yeah.
Very good. So you remember that part. If a number is a big number, that number will be positive. You're moving it positive places. If it's a little number like 0.7136, your exponent will be negative. All right, so one more. Let's suppose we had 0.0762, and we want to write that in scientific notation. Well, it has to move to here. So it's 7.62 times 10 to the what? How many places did I move it? -2, and it's a tiny number, so it's going to be -2. That's how scientific notation works. Now, what if we have, which you did in chemistry, you had problems to work that involved scientific notation? Now, these numbers are not nice, so go ahead and get your calculators out. I can't remember, yesterday did we talk about that you could, we have a loaner program for calculators, so we talked about that? Okay, if you don't want, you have to have a graphing calculator for this class, not today, whatever calculator will work fine today, but you have to have a grapher for this class. There will be problems that you can't do without a grapher, okay, you gotta have it. So, maybe you have one already, ideally you already have one. If you don't, you can go buy one, get a TI, Texas Instruments, 83 or 84, plus, not plus, colored, not colored, I don't care. I'm old school, I got the old one, this is the kind that uses batteries. The newer ones are rechargeable, and I got a charger over there. Doesn't matter to me, whatever you want, whatever's cheapest. If you don't wanna buy one, cause mom bought you one and then you lost it, and she said, I'm not buying you anymore, or you just don't wanna buy one, Cathedral has a loaner program where you can sign one out for the year, and you keep it, goes in your backpack just like it's your own personal thing. But at the end of the year, you have to turn it in with all its parts working and, everything, or you get charged $120 for it, but it's free. You gotta buy batteries, you supply batteries, but, not good this time. So, if that's what you wanna do, let me know, we can do that after school.
So what was the model number again? Oh, yeah.
83 or 84, TI, 83 or 84. You probably will get an 84 because I don't even know if they make 83s, but if there's an 83 or something on Amazon, you wanna get it, that's fine. Has the same functionality. Okay, so, these numbers are awful, I don't wanna multiply and divide them, so that's why we have our calculators out. I want you to look at it carefully though, because there's really two different things going on here. We have regular numbers, regular decimal numbers, and then we have these powers of 10. So we are gonna do the problem in two separate pieces. We're gonna take care of all the regular numbers first, regular decimal numbers. So, what is going on between these two? Are these two numbers being, these two right here, the green ones here, are they being added, subtracted, multiplied, or divided? Multiplied. So we're just gonna take our calculator and we're gonna do 3.16 times 1.43. All right, now what about this one? What's going on with him, this green number right here? Divided, so I'm just gonna do divided by 1.23. And I'm gonna have to round it off because it's some hideous thing. So 3.67, I'll say 4. I'll just round it off that many places. Okay, did everybody get that? Okay, now, let's take care of the red parts. This is the decimal part of the scientific notation. Now I have to have a 10 part. Okay, so let's think about this. That is a 10 to the 5th. I'm gonna write it separately over here, 10 to the 5th. Now what about this guy? What's that? That's really 10 to the 8th on the bottom. And what about this guy? He's 10 to the 10th on the top. So on the top of my fraction, I have 15 tens. On the bottom of my fraction, I have 8. So what's gonna happen when I start canceling? I have 10 to the 15th over 10 to the 8th. Who has more? Top. How many more? 7. So it's times 10 to the 7. So when we're doing this, we're gonna deal with the decimals first, and then we'll handle the
Under my
tens.
seat.
All right, there's another one. Let's try this one. This one looks easier. All right, so 2.5. All right, so first things first, let's take care of our decimals. What are you gonna do with these two numbers? That's subtract, multiply, or divide? Multiply, so let's multiply 3.85. 19.096. That sound okay with everybody? All right, now we'll deal with our tens. This is easy, I'm gonna make it or anything. I got 10 of them, and I got 13 of them. So altogether, I have 23 of them. Daniel's there nodding his head thinking, this is so cool, this is so fun. But I'm gonna tell you, we aren't done with this problem. There's something wrong with this problem. We made no mistakes. This is the absolute 100% correct first step. Leilani?
That should remove the decimal.
Exactly. Remember when we write a number in scientific notation, how many decimal places am I allowed to have before the decimal point? 1. So we didn't make any mistakes. This is just the way it worked out. But I have to move it now and make it 1.9096 times 10 to the something.
22. 24.
So it's either 22 or 24 because we moved it one place, right?
24. Yep.
Here is the way I remember it. I am, there's so much stuff to remember. These two numbers have to be the same. I'm just rewriting this number. If I made the first part of the number smaller, isn't that what I did? I went from 19 to 1.9. If I make the first part of the number smaller, then the second part of the number has to get bigger, because otherwise it won't balance out. So those of you that guessed 24 or figured out 24, right on target. All right, and then we have our property conversation. Can anybody give me a property? Any property. You don't have to do any of these problems. Just do you remember the name of a property?
Distributed.
Distributive is a property. All right. So let's look at A, B, C, D, E, F, G, and H. Does anybody see any of those that appear to be distributive? Do you know the distributive property well enough to see it in there? What? A is distributive, absolutely. A is distributive. You can abbreviate. Anybody see another one? I think there's another one.
H.
Lincoln?
H.
H. Yep, H is also distributive. All right, is everybody good with that? Distributive property. We practiced some earlier. Good. Okay. Can anybody name another property? Just, you don't even have to remember what it is exactly, you just remember it's a property. Oh, I heard somebody say reflexive. Reflexive is a great property. We won't be using it in this class. We're doing properties of operations, not inequality so much. But yes, A equals A, reflexive. We use it in geometry all the time.
Is reflective one? No?
Reflexive, that's what she
Reflective.
said, yep, yep. What? Okay, we have things called the additive identity and the additive inverse. So the additive identity and the additive inverse. Now, what these properties do, okay, the additive inverse is the opposite, it cancels out. So that property looks like A plus the opposite of A is 0. I'm just using A, you could use P or X or something. That's the additive inverse property. Is that on here anywhere? Nope, I don't see it. The additive identity says if you add 0, you get the same thing back again. Do we have that one on here? D is your additive identity. You can abbreviate. Oh, right, additive identity. Now, these are the additive versions. There are also the multiplicative, or the equivalents to multiplication. The multiplicative, and again, you are going to abbreviate. You are not going to try to write all this stuff out. But the multiplicative identity says A times 1 is A. The multiplicative inverse says A each other out. Inverses cancel each other out. Here it's addition, here it's multiplication. Do you see either one of those, the multiplicative identity or the multiplicative inverse? Are they on here?
Yes.
What's what?
E is the identity. Or F, my bad.
F is the multiplicative identity, yep. And what's G?
Inverse.
That's your inverse, very good. All right, does anybody remember any other properties? Yeah, what? Yeah, good, you guys are awesome. Reflexive, symmetric, and transitive are the properties of equality, and those are great. We're not talking about those right now, we're talking about properties of operations, but yeah, symmetric is the one that says if A equals B, then B equals A. Perfect, perfect. How about commutative and associative? Do those words sound familiar to you?
Yes.
Anybody remember anything about either one of them? All right, the commutative property of addition says A plus B equals B plus A. The commutative property for multiplication says A times B equals B times A. So the commutative property takes two things, either adding in the other order or multiplying in the other order. All right, is that happening in any of these problems? C? Definitely C, and that would be multiplication. Commutative for multiplication. And some of you might be confused, but if you look at problem C, you have 6 times x plus y, and then you have x plus y times 6. See how it flipped? Okay. I think there might be another one. B is commutative of addition, because in the parentheses on one side is x plus y, but on the other side is y plus x. Last one, E. Did any order change? No. Look at the numbers. 643, 643. The order didn't change. What did change? The parentheses, the way they are grouped.
Yep.
And that is called the associative property. For addition, it looks like this. And for multiplication, it looks like this. So what you need to do to keep this straight is commutative has to do with order. You flip it. Associative has to do with how things are grouped. So no order changes, but you're grouping them differently. And that would be problem E. Associative multiplication. Okay, now I have posted, properties are tough. They're hard, we don't use them a lot. I mean, we use them all the time, but we don't talk about them a lot. But I promise you on your final exam, semester exam, there'll be one property question on the exam. I put some extra practice in the Canvas. Actually, I think I included it in your notes. Look at the very end of your notes packet. Yep, there's an extra practice sheet, extra property practice sheet there. And the answers are on the back. So if you have some free time and you want to practice your properties, because we did this pretty quickly, you can absolutely do that. Okay? All right, that takes care of P1. So guess what, my friends? Homework will be due on Tuesday. Your P1 homework will be due on Tuesday. Feel free to turn it in on Monday. Just the front side, E1, one page, front side. Turn it in.